This question on dimension of unit. For which of the underlisted quantities is the derived unit m, l raised power 2, t raised power minus 2 correct? So we are to find the quantity that has this as its dimensional unit or dimensional formula. So quickly, what we're going to do, we're going to take each of these quantity, define them mathematically, and write their dimensional formula and see the one that relates with this. That's how we know our answer. So finding the dimensional formula or unit of a quantity means that we should find how mass, length, and time relates relates to that physical quantity. That we should find how these three main fundamental quantities relate to that quantity. Okay, so let's start with moment of force. Moment of force is defined as the product of force times what? Perpendicular distance from line of action. So that's the definition of moment of a force. And then force on its own, if you split it further, the mathematical definition is mass times acceleration, then times what? This distance. This sign here represents perpendicular. Don't mind me, represent perpendicular. Okay, so times what? Distance. So mass here, its dimensional unit remains m. Then acceleration A is defined as what? Velocity over time. And velocity on its own is defined as what? Displacement or distance over time. Then another over time. So distance, the dimensional unit for distance is what? Length. Distance is a length and time remains time. So there are two times here, that will be t raised power 2. So mass times acceleration will be L over t raised power 2 times distance. Distance is L. So this will be m. L times L will be L squared over t squared. If you take this t to the numerator, it becomes minus 2. So you see that moment of a force has this as its dimensional unit. So I is there. So let's see work. Let's find the dimensional unit for for work. So dimensional unit for work, first, before you find the dimensional unit, you have to define the quantity first. Work is defined as a product of what? Force times distance covered. So you see that work has almost the same definition as moment. The only difference is that in moment you are talking about perpendicular distance. That's distance that is in 90 degrees from the line of action. But when you say work, what we are considering is the product of force and distance, whether it's perpendicular or not. So that's the only difference between moment and work. Moment and work have the same unit. Okay, so since it's the same, it will still go with the same analogy. So the dimensional unit for work will be what? ml squared t minus 2. So let's do for that of acceleration. Acceleration is defined as what? The change in velocity with respect to time. We already did that, and we've seen here, and we've seen that acceleration dimensional unit is what? L t raised power minus 2. So which is not the same with here. So you see that moment and work have this as their dimensional unit. Acceleration dimensional unit is different from this. So the answer is I and II, option C. The answer is I and II, option C. That is Moments of force and work, they are the ones that have this as their dimensional unit. Thank you.